Alrighty. Well, welcome everyone. My name is Dev Debrat. I use he, him pronouns, and I'm an Associate Dean of Admission here at Reed. And today's session is all about the physics department here at Reed. So I'm going to pass it over to one of my favorite faculty members, that's for sure, Allison, to talk a little bit more about the physics program.
All right, awesome. Welcome all. So I'm Alison Crocker, physics professor, use she, her pronouns. My own specific research is in astrophysics, star formation in nearby galaxies, which I study observationally. And I'm currently teaching the sophomore spring physics class, which is modern physics, that maybe some of you will be in 2 or 3 years. So I have a brief overview of just how the department works, what our courses are, who's in it, and then we can get to your questions after that. So I'll launch into a very brief slide deck just to have some words to help us through things. And then, yeah, we'll end that and do questions. So let me do my share screen. Share screen. Okay, I think we're sharing that. So overview of physics major, just want to let you know what the courses would be to start. And the first 2 years are pretty typical, I think. We have you doing sort of intro, physics, mechanics, and E&M in the first year, along with the math courses that go along with those. The calculus is a co-requisite, so if you haven't had calculus before, totally okay, but you will need to take it at the same time. Some people will pass out of that. That's totally fine. You can do the Math 112 in the fall instead. Math offers all their courses kind of very modularly, both in fall and spring. And then the second year, we've recently introduced this Introduction to Electronics course, which is a lab-only course alongside our typical fall course in oscillation and waves. And that gives everyone really leveling up in sort of math methods that are applicable to physics, is the main goal of that course. And then the linear algebra and vector calc in that second year are the required math courses. And then there's the course that I'm teaching right now, the Physics 202 Modern Physics, which is super cool because it's special relativity and sort of intro quantum mechanics, some really cool stuff that we get to treat for the first time in this course before seeing it again at a deeper level in junior courses. And those junior courses go like this. There's a lot in the junior year, in particular in the physics major, but there's no longer any required math courses sort of at the same time. So there's classical, E&M, advanced laboratory, all in that junior fall. And people typically are in the physics major are taking these at the same time. And so we have usually roughly around 20 students per year, and you really form a good cohort with your students because you're in all the same classes, at least from the physics side of things, all the time. And so you get to know your other physics majors. It's not like there's only 6 majors a year and you're always intermixed either with the class below and class above. We have enough people every year that we can offer the courses every year, which is just not always the case at all institutions. So we have those junior level. In the spring, you do quantum mechanics, the full course for the first time, as well as an advanced laboratory 2 course, which is very project-based. You really, along with a lab partner, sort of tackle 3 independent experiments over the course of the spring and write them up. And then in the 4th year is the Reed thesis, which I'll say a little bit more down the road, but that's the only true requirement of the senior year of the physics major. Other than that, you can take what you like, maybe more upper level electives within physics, maybe something totally different. A plan that would work for sort of doing a physics major here at Reed could go something like this. I bolded the extras that I added in here that are the not physics things that you do have to do. Hume 110, of course, and then just different options for group requirements. You have to take them. You'll find something you like doing. The group A, group B are very broad. And so this person chose to take French and dance for their group A, could have also taken English courses, could have also taken theater, very different paths possible. And this person did philosophy and linguistics for their group B. Totally other options there. You could do economics, you could do sociology. There's other things, you could do history to round out your coursework here. And all those X marks, the one in the junior year and the 6 in the senior year, are things that are just totally up for grabs. And you could move some of those earlier and move group requirements into the senior year. That's fine too. But those are places that come your senior year, you can either put other courses and maybe do a minor in French, or load up and take some of all of these physics electives. We have a lot of physics electives. We offer at least 6 per year, which again is not a common thing. Because we have at least 20 majors a year, we have the faculty to year after year offer these electives, which are not required for the major, but are really good things to take if you have the time and interest in sort of furthering your physics knowledge beyond the core courses. So some of them we offer every single year. The first 4 there, classical 2, thermal, quantum 2, electrodynamics, we always offer those. And then the remaining 6, we usually offer those every other year, at least 2, usually 3. And so that you'd have the option of taking those either in your junior or senior year. The thesis, you may have heard if you've read some toward here at Reed, right? It's this year-long independent research project on a topic of your choice, mentored by a faculty member. By the end, you produce a written thesis document. You give a short seminar to our department. So those are upcoming for this year's thesis students. Those will start happening the Wednesday after break. Really looking forward to what the seniors have been up to. And then you do have your oral thesis defense with 2 faculty members from physics, your mentor, someone else, 1 person from the division and 1 person from totally outside the division. And so the outside, it's super great. You sort of bring together professors that you've had in different contexts, and they all get to witness you be the total expert on your thesis at the end of the day. Some examples, I just updated this just now with last year's theses. I couldn't do it with this year's because they don't actually have their final titles yet. So I didn't want to misconstrue anyone's thesis. But these are some from last year. My student worked on extracting cosmological parameters from cosmic microwave background temperature map data. There was an experimental thesis on feedback control for an inverted pendulum, something that with the right parameters, you can keep upright for a while, studying that. There was a thesis involving a study of the heat loss at the Reed Research Reactor, our nuclear reactor here on campus. And then there was a quantum theoretical quantum computing example thesis there at the bottom, these spin 1/2 chains that Vivian studied. So that's across different fields of physics, just an example of some of the theses from last year. The people mentoring these theses and who would be teaching your courses here are the 7 of us. Mark Beck works on quantum optics and laser physics. He's been on leave. He'll return after next year. He's been a program director for the NSF. Noah Charles works on theoretical dense matter. I work on astrophysics. Joel works on gravity and quantum mechanics. Jennifer Heath does experimental solid state physics. Lucas does nonlinear dynamics. So that was that inverted pendulum, cool thesis, and atomic, molecular, and optical physics. And Daryl works on condensed matter theory as well as quantum information, kind of quantum computing. So that's the set of us. And any given year, someone's on sabbatical. So next year, Joel's going on sabbatical, but we'll have a visitor and be able to offer all the cool classes that we usually do. Just a few things beyond courses here in the department. We have a seminar every single Wednesday. Everyone gathers at 4 o'clock beforehand for cookies and tea in the physics lounge, hangs out for a bit, chats, the speaker's there. And then at 4:30, we go into the seminar room and hear a talk from someone either sort of in a physics adjacent field in industry or someone from academic physics, talking about their research. Sometimes, like soon to happen in the spring, we'll hear the seniors talking about their research, their senior thesis projects. In the fall, we also invite people who've gone and had summer research experiences to come and tell us about those at the beginning of the fall semester. So it's every week, slightly different things at different times. We always have a physics-focused talk midweek. There are research opportunities. Largely, these are thesis, but we also, a number of us take summer research students over the summer and are happy to do that. So I think we have about 7 or 8 students that we'll hire this summer for summer research. But that's not the only opportunity for sort of paid work within the department. We do have a lot of really cool jobs, actually, because they are paid jobs for either grading or lab TAing. But while you're doing those, you really cement your own knowledge of whatever you're grading or lab TAing. And so it's sort of a win-win. You get paid, it's physics related, and you really deepen your understanding. When you teach, you always deepen your understanding. So those are cool things to just be more part of the department and be paid at the same time. And then I have a few astronomy sort of things. We have a weekly co-op journal club that we get together and talk about a recent astro paper. We also have a telescope on the roof, which during clear periods, which aren't all that numerous here in Portland, but during clear periods of the year, we're able to run and students can be trained to be telescope operators and then go use it on their own. So that's pretty cool. For study abroad, there are study abroad options here at Reed. There aren't any yet that are specifically geared towards physics. I have a student who's trying to look into it and might go to Paris next year. Generally, we think the best time to do this is probably your sophomore year, but we're happy to work with you if you have ideas to sort of verify what courses might work for what if you go study abroad while you're here. And then there are these 3-2 engineering programs. And so we have ties to programs at Caltech, Columbia, and Rensselaer Polytechnic. And these you do 3 years here at Reed, and then you go to the other program and end up with also a bachelor's in a specific engineering field. So to do this, you do need to know kind of what engineering field you want to go into. The requirements are different for the different subfields of engineering, and the degrees are specific. So you'd have to be admitted to a specific program for electrical engineering as opposed to mechanical engineering. And so if this is of interest, and you come here, you just need to be in really good contact with the advisor for 3-2 programs from the beginning to make sure you cover all bases. There's certain grade GPA minimums, and the admissions is not guaranteed. In particular, Caltech has been has admitted one student, but they didn't actually go in sort of past 2 decades. And so it's not like a guaranteed admissions program in any way, shape, or form. But there have also been, I think in the past 10 years, I think there are there's 5 students who've actually gone and done one of these engineering programs. So it's not particularly common, but it's also, 1 every 2 years someone's doing this. Okay, and then I just put this up here because I do always get questions. How does first year placement work? I took this AP course. It promised me I get out of intro physics in college. So this is the way we do it here at Reed for first year placement. Unfortunately, we can't do the IB exams because it's not calculus-based physics. But the AP exams are. And so if you get a 5 on BC Calculus and AP Physics C Mechanics, those count for placement out of Physics 101, the fall course, and a 5 on BC Calculus and a 5 on AP Physics C Electricity and Magnetism count for placement out of Physics 102, the spring first year course. If that situation doesn't apply to you, you are welcome to take a placement test when you arrive here during orientation. Registration occurs before the placement test. That's okay because the course you would place into if you place out of the whole first year is at the same exact time as the first year course. And so your schedule won't get messed up. It won't take huge rearrangement. And so it's totally fine. You can take the placement test during orientation week and we'll figure things out from there. Okay, that was my very basics on the physics department here at Reed.
Awesome. Thank you so much. We've got a lot of really great questions that have come in while you were presenting. So I'll just get started with the first one. Does the introduction to electronics imply analog circuit design?
Yeah, I mean, it's pretty well led for the most part because many people are totally new to analog circuits, but it is analog circuits working with breadboards on specific projects that at the beginning are pretty well spelled out what you should do, and by the end are a little more freeform.
Great, thank you. And then what is the environment of the classroom experience like? Is it lecture based? Is it more conversational in nature?
Yeah, so a lot of it is more lecture based. The intro physics lecture is still like a lecture of however many students are in the course, but then you also break out into conference, which is 14 to 18 students problem solving with a professor, not like a grad student or even a student TA, like it would be at a big state school or something. It's with an actual professor in that smaller environment. So I guess yes and no. There's the lecture based, and then there's that smaller component. And then as you go up to higher levels, we do different things. Different professors organize their class differently. Lectures largely a part of most of them, but then people use small group work differently as part of their courses. When the course goes under like 10 students, then we can do more different things with it as well and are likely to. But when it's still like 20-ish people, it's largely lecture based with perhaps some breakouts and time to ask questions and chat. And people, it's I think a pretty good dynamic. Like I have 28 people in sophomore physics. It's great to have so many people. And I do get questions all the time. And I think we also get through like a good amount of material each class. So a mix, but I'd say leaning towards lecture.
And you spent some time talking about the thesis, which I know is a tradition here at Reed in every department. Are there opportunities to participate in research outside of thesis?
There's a lot of the effort of the faculty members does go into making that thesis experience there for everybody. So that's our focus during the school year. I mentioned that we do have summer research students, so that's a way to apply to and get involved in research earlier than senior year. And occasionally one of us will have a project that's sort of amenable to having involvement in before the senior year. So Jennifer Heath has had a handful of students working in her lab during the school year. She's on sabbatical next year. I don't know if that's going to happen next year, but that will happen when it sort of works for a given professor. But unfortunately, with 3 or 4 thesis students every year, a lot of our school year research effort goes in that direction.
And is it my understanding that there are like fellowships and other things that exist for students that are interested in doing research that is maybe not necessarily tied to their study at Reed? Is that accurate?
So fellowships, I mean, there's summer fellowships. If you figure out somewhere you want to work outside of Reed during the summer, there's Reed money to go and maybe do that, as long as you find a professor willing to host you at another institution. Um, and is that what you meant? Or was
Yeah, I
there?
think so.
Okay.
Yeah, that's great. Thank you.
Mhm.
You were walking us through like a plan of a student schedule in one of your slides. How would that plan look different if a student were pursuing that 3-2 engineering program?
Yeah. So a lot of what's required for this physics major in those first 3 years remains the same. Thesis gets evaporated from the final year. But each of those engineering programs usually has a few extra requirements that we don't actually require. Um, and so often it's chemistry. If it's sort of electrical, it might be more computer science. There's some other coursework to fit in, and you have to fit in all of your Reed group requirements in the first 3 years. So it looks like that physics major backbone that I showed, adding in, making sure all the group requirements fit in the first 3 years, and then usually an extra course or two, depending on what subfield of engineering is being aimed at.
Gotcha. That makes sense. And then how would the physics major itself work if a student declared their major maybe a little bit later on, or even potentially switched later into physics coming from another major? And then the second part of that question is how would the major work if a student had a double major, which I know is very rare here at Reed.
Yeah, yeah. All right. So switching in late, it's possible, and it really will depend on the student and what they've done elsewhere and how much math they've done. And so if it's of interest, we'd really work closely one-on-one with the student. I've known in the past someone did take a summer course somewhere just because they wanted to jump into our sophomore courses instead of our first year courses. And working with that student, we found stuff that would work and found a way for them to do that. Jumping in, I mean, it's still possible to start everything, actually, even Physics 100 in your sophomore year and finish. Um, it is not common. It's not necessarily even recommended because then you don't have as much physics background before you start your thesis, but it is possible. I advised someone who came back to Reed after like a decade gap, and we figured out something to do that was kind of along those lines with the time she had left at Reed. So it is possible to start later. It would be easiest to switch from a major like math or maybe computer science, where some of the required courses that you were taking already for math or computer science at least meet the math requirements of the physics major. And then you have less total sort of catching up to do. The double major is, yes, very rare at Reed. And it is not rare because people here are uncurious and don't take courses in lots of different things that would be a double major elsewhere. It's not common here because it requires you to write two whole separate year-long theses. Um, and so it happens once in a while. I think I just signed paperwork for someone who is intending to do a music and physics double major. And what you do is you look at the two sets of required courses for the two majors, and you make sure you meet all of the requirements of both, and that you have time to thesis in both for your senior year, which means 4 credits your senior year, because one fall credit for each thesis in the fall, one full credit for each thesis in the spring. And so that's 4 out of maybe 6 of your senior year credits. You can take 8. So yeah, double majoring is rare, but it's possible, and it has been done with physics. I've also seen someone at least plan, they didn't end up going through with it, a philosophy physics double major.
Great, thank you. And what courses do you teach outside of modern physics?
Yeah,
I think you touched on some of the astrophysics, is that correct?
absolutely. Yeah. So I teach astro, the upper level astro, that is more taken by majors. I teach a lower level astro course, which is open to everyone campus wide, which is a blast to teach. And then we also, in the physics department, we don't really like only have a few courses. So who knows what I'll teach? We still don't know what we're going to teach next year. I've taught the intro courses, I've taught thermal physics. I'm sure I will teach other of the upper level courses in the near future, maybe even next year. So you'll find that we like keeping it fresh. Different departments, even at Reed, are different. Some departments just have their courses for those professors and they do them, and that's that. But we keep it mixed up because then we feel we know the material and can sort of interweave and teach across the curriculum better. And then we have a better picture of what everyone's coming into thesis with, what we can expect when we're actively kind of teaching the different courses.
And let me tell you, as someone that did not go to Reed and went through a program where professors just taught their classes only, this Reed model is really nice because then you get to see from a lot of different you get to hear from different professors and get a lot more exposure that way as well. So I know relationship building is really key here at Reed in our academic programs. Can non-physics majors also become telescope operators?
Oh yeah, totally.
Awesome, awesome. I have another student that has some questions about the AP credit piece. I have a couple of questions that are coming in about that. So I am going to skip around here. If a student didn't take AP Physics Mechanics, but did take AP Physics E&M, can they still place out of Physics 102?
They can. We'll still have them take Physics 101 in the fall. Um, so it doesn't help as much as placing out of both because you can't get into the sophomore course. But you are welcome, if you think your mechanics knowledge is solid, to take the placement test and see if you have that level that we're looking for the fall course as well.
Gotcha. And if a student does place out of Physics 101, but not 102,
Mhm.
is there an appropriate physics class that would replace that in the first year?
So there isn't anything for the fall except what we've had and has been really successful for the past 2 years is that we've had students. I mentioned that there's the big lecture for Physics 100. There's also this conference, this active problem solving session. And what we've had is that set of students, which has been 3 to 5 people who've placed out of 101 but not out of 102, take that conference only part, so just the problem solving section for 0.5 credit. So it's showing up once a week, 80 minutes, and kind of reviewing the mechanics. So you're nice and fresh for the spring, and also you're meeting the other people in physics. So people, I think everyone so far has taken us up on that offer. And we found, I think the students have found, and we found that it's been something that's really good. So it's not a full course, but it is something to do to keep your physics fresh during that fall, if that's your placement situation.
Gotcha. That makes sense. If a student has a 5 on AP Calc AB and a 5 on Physics Mechanics, do they still have to take the entirety of Physics 101?
I'd say come and take the placement test because we're right now only doing the 5 on BC and the 5 on mechanics. So come and take the placement test. It will involve some calculus. If you show that calculus physics knowledge melded well enough on the placement test, then we're happy for it to place you out.
Gotcha. And is it possible to place out of physics classes beyond 101 and 102?
It would take probably it being actual college credit from somewhere else. So if that's your situation, you'd work with the professor here that's in charge of transfer credit, and we'd talk about the coursework.
Gotcha. Awesome. And then what support is there for physics students, especially with the junior exam? I guess
Oh,
it's the junior qual.
the junior qual? Yeah. Maybe I can overview just a little bit about the junior qual in case folks don't know. Junior quals are short for junior qualifying exam. You have to do it in whatever your major is across Reed. Ours is a test that is very strictly on the first 2 years worth of physics courses. So physics 100 courses, physics 200 courses, and that's it. And we actually push it so people don't forget those courses. We push it as early as possible in the junior year. So it's when you show up junior fall that you take this junior qualifying exam. And so the resources that are available, I mean, we just had our sort of information session with this year's sophomores explaining how the exam works, answering all their questions, and providing them with uh, we call it the junior qual kind of study book. It's a set of practice exams essentially that just show the format and can be used for studying over the summer. So people know what it's all about, what they should review. But it is really tied. We check in when we write the exam, with the professor who actually taught that group of students 101, 102, 201, 211, 202 to make sure the problems are materially covered. And so we really promise that it's not like you're studying for something that you haven't been taught. We really tie it to the courses.
Gotcha. And what if you're interested in doing research more advanced subjects that Reed doesn't offer courses in? This person, the example they gave was the quantum field theory and this question I think is specifically asking about the thesis.
Yeah, I mean, we have professors who can mentor a quantum field theory thesis. So that would be fine. There are subjects that we aren't experts in. That one would be fine. And that in those cases, I mean, a few things are possible, right? We do let students sort of choose their thesis topic. Um, and then we find a mentor. And generally we can find someone. If we can't, partnering with an outside mentor and having sort of mentor within Reed is totally an okay thing. But the student would be required to find that mentor if it's a subject that they're really passionate about and sort of beyond our curriculum. And that's happened. I mean, and it's more happened not particularly because it's sort of advanced, but it's just it's a subfield that we don't offer. We're 7 people and physics is broad. And so we don't have experts in every last thing, but often someone will go on and do a summer research project somewhere, fall in love with some subfield, and then their thesis might take that summer research even further and remain mentored by that summer research person, in particular when that was a really good pairing of student and mentor over the summer.
Yeah, and on the topic of summer research, how does Reed help students with attaining those research opportunities?
Yeah, so the we can sort of in our own subfields we're the strongest because we have networks and can help connect students to different places depending on what they're interested in. Some of it is it depends for each student, like what they're interested in doing. Some will be able to apply for REUs. Some will be able to apply for working with us in-house. And then others will be able to try to connect with someone outside at maybe a R1 research institution that is happy to have an undergrad do a thing for the summer. And then we can help them connect to Reed money to pay for that, for doing that type of research.
So thank you. And this might be like a CLBR alumni relations question if you don't know this off the top of your head. But do you know what the mix is between students that want to go on to grad school and continuing learning in physics or astrophysics versus how many or what percentage of students go on to join the workforce?
Yeah. So we have about a third go on to a graduate degree within 2 or 3 years of leaving Reed. Um, Maybe more would be interested. It's pretty competitive these days. It may become more so. It's hard to predict. But I mean, we have a very intellectually curious and interested group of students. And so we do have a large fraction heading to grad school. And I'd say even more are really interested in sort of pursuing intellectual pathways close to research, even if it doesn't end up being in grad school. And so some of those, like one of my thesis students went off, I think he may go to grad school actually soon. Hopefully he'll get in this year, but he was a telescope operator on Hawaii for 3 years after graduating. And that wasn't in a graduate program, but it was very much within sort of research land. But then we do also totally have people go off and do applied things. So we had a great talk by a Reed alum, totally awesome woman who's working in cybersecurity. I didn't even think it was interesting at all until I heard her talk. Kind of seems more interesting than I gave it credit for. So we try to keep bringing people like that to campus, often Reed alum, to tell us what interesting things they are doing in industry land, just to give that perspective to our students as well.
And we have a student who's really interested in getting a copy of the syllabi from the different classes to review before they are enrolled. Is that something that's possible? And how would they go about reaching out to do something like that?
Um, Maybe we can partner with admissions and send like a few example syllabi so that those are available for students.
Okay, yeah. And if that's something you're interested in, I'll put my email address at the end. And if you want to reach out to me, maybe I can connect with you offline about that, Allison. Um, Someone's asking, how difficult is the thesis?
It's it's new and different. And the challenge, it presents a challenge to everyone in some form. The challenge is very different for different students. And I even have a hard time predicting what the biggest challenge for any student will be. But it's certainly a challenge. But it's not insurmountable. By the time you get there to thesis, you're ready to do it. Something will be hard about it. Sure, that's fine, because it is a big year-long project. You have done nothing quite like that before. And so sometimes it's the writing, sometimes it's the actually doing of an experiment, sometimes it's a really hard calculation that right? It is not a problem that's in the book that has an answer in the back of the book or somewhere in some solution manual. It's a problem that no one knows the answer to. And so you can stare at it for a very long time and maybe actually not make progress. And that's also okay. You try things and you document the things that you're trying, and that's still a thesis. And so it is not something that unless you don't work on it, you can't really fail a thesis. If you work on it, your 8 to 10 hours a week, that should be for a course, you will have a thesis at the end of it. Will something be challenging along the way? Absolutely. But that's why you will grow during the process. And that's why everyone at the end of it will be super happy for all of each other at thesis parade and spray champagne and be happy.
Thank you. I love that answer. That was great. Um, for students that are considering that rare double major process, does does the program offer summer courses to allow students to complete or to progress faster?
We do not have summer coursework, but you are welcome to take it somewhere else, at home, at an institution close to your house, somewhere else, somewhere here in Portland. We know things that work. And so if that's something you need to do to progress towards a double major, reach out to both major departments. Maybe you'd be wanting to do group requirement work during those summers. That's a possibility, but not at Reed.
And then office hours are something that we often hear about. Can you talk a little bit more about what office hours are, what kinds of conversations happen, and how often do those happen?
Yeah, we have office hours, I'd say at least 3, maybe 4 hours a week, I think, typically in physics. And I think that's fairly standard. And what that means is that I am here at my desk and students are welcome to come in and ask me questions. They can be questions on the course. They can be questions about summer research. They can be questions about just general advising for things here at Reed. So my door is really open for all of these things. I'm teaching this 28-person class right now. Often a lot of people will come in, particularly the office hours before homework, because they have questions on the homework. And then people will kind of check in and see if they can enter at the same time. If someone has a similar question, that's totally fine. But if someone's here for advising, we kind of have to say like, no, just like wait a little bit outside the hall. And so, yeah, it's times that we're just available for student questions of whatever sorts. Like what's behind me is actually due to office hours. Sort of everyone had lab reports due middle of last week. And so we're talking about different ways of just representing the data and sketching that out on my Blackboard. And we really use the Blackboards a lot. Often we'll have, you know, like a student comes in with a question, we don't want to just like answer it. We want to like help guide the students so that they find the answer themselves. And so we do a lot of discussing, working on the board together, and making that happen.
And going back to the topic of placement tests,
Mhm.
what sort of level of physics is Reed looking for in order to place out of those freshman courses? And I believe it's those IB classes, or those, excuse me, those AP classes you were talking about. But is there an example of some of the content that might be on these placement tests?
I mean, I think you can use the AP Mechanics and AP E&M tests as a great guide. So it is calculus-based, fairly standard intro textbook. Any intro college textbook would work. Giancoli, we use Knight, but Giancoli, Halliday, Resnick Walker, Knight, all of these would work as it's pretty standard material on the courses. And the AP syllabus would be a first guide. If we can get some syllabi to admissions, that would be a second guide, but it really won't be much different than the AP course syllabus.
Awesome, thank you. And if you're interested in doing both physics and math, is it beneficial to do an interdisciplinary physics math major?
So in rare cases, yes. But what is the rare case? So it's again, if you do an interdisciplinary major, it means your thesis needs to not be anything in math or anything in physics, but it needs to be constrained to like the overlap between these two fields, which is a pretty big constraint. Yes, physics, there's tons of math and physics, and there can be physics and math, but the overlap zone is not everything. And so it does put that constraint on your thesis. And so there is an interdisciplinary major that probably, I think we've approved maybe out of this class of 28, I think there might be 4 or 5 math, physics, interdisciplinary majors. So it's not very uncommon. But it does mean that more limited thesis experience, and it means you have a little less freedom in the courses because you'll put down to paper a promise to take more prescribed courses in both fields. Whereas if you're just a physics major, you have some sort of freedom of whatever you want to take in math. Or if you're just a math major, you can take whatever in physics and not worry if it's like what the other department wants for this interdisciplinary major. So it is the right thing in some cases, and it's not the right thing in other cases of people who are interested in both physics and math. Sometimes the best answer is to do one or the other and just a lot of coursework in the other field.
And jumping also one more time back to research opportunities, what does the process look like for applying to summer research?
So within the department, we put out a call early spring semester and tell, it's pretty informal. We list the projects we're going to have, who they're with, and what we're looking for as the basics. And students send us also a pretty informal note that they're interested in these projects and why they think they'd be a good fit and why they're interested. And then a few weeks later, we get back to students with offers, and hopefully that's accepted, and then we have sort of a match for the summer. For outside of Reed, the timescales, usually the applications for open research opportunities for undergraduates go from sort of January, very last applications are early March. And so we write lots of letters for those in that time period. And then students start hearing back March, late February through March. Yeah, so then that's really the two most common pathways. If you're going to go the individual finding a professor outside route, that might have a different time frame.
Great, thank you. And then I'm going to jump around here because I've got a couple of questions about the research reactor.
Mm.
So can you talk a little bit more about how is the research reactor available to students? What kind of projects is it used for? And are there campus jobs related to the research reactor?
Yes. But I'm not a super expert because reactor is actually quite separate from the physics department. And so it lives over in chemistry land, more than in physics land, even though physically it's not even in the chemistry department. And it's really a separate entity. There's 2 staff members who are the reactor staff members. And then the people really running the reactor day in, day out are undergrads who have been trained in the reactor. And so, yes, there are paid positions for both operating, and as I understand it, there's also the students themselves train the next batch of reactor operators. There's a course that you can take in that's called reactor seminar. That just means you're being a reactor trainee, and it can show up in your transcript, but it is 0 credits because it's not actually an academic course, but it does signal that you were a reactor trainee. And research projects. So as I understand it, reactor operators can do their own reactor projects as they want to and see fit. And so I've known some physics students who've been very involved in the reactor, and they do their own research projects there and then go to conferences where they present that work, and then go on to jobs that are associated with nuclear engineering after Reed, because it's a skill set that is not super common and is still quite needed. So yeah, that's a bit about the reactor. I don't know if it covered all 3 of your questions.
Yeah, I think so. I think it was the types of projects, how do students get involved, and if it's a campus job,
Yeah.
getting to work with the reactor. And I believe you hit on all of those. Um, Great. Are IB students eligible to take the placement exam, even if the IB physics credits can't be used to place out of the courses?
You are welcome. Everyone's welcome to come and take the placement exam. It will be on the subjects with calculus. But if you feel like your experience with calculus merged with your experience with physics might be good enough for that, come and take it.
And I'm gonna ask this next question, but then I'm gonna elaborate a little bit more um, because I'm also curious. So the question is there a communal study space for physics majors? Do students work together regularly? And I'm also wondering, and this is the part that I'm ad living here, is if you can just talk a little bit more about what the student culture is like within the physics department. Is there a lot of that community building? If you could elaborate a little bit more about
Yeah,
that.
happy to. So yeah, we a few years ago moved the physics student lounge to a new space, and it's worked out great. It's sort of just more of a communal space. It's on the first floor. It has a fridge and a microwave and some tea and coffee making stuff and a sink. And so it's a big space. There's like 3 different tables that people can sit and study at. There's blackboards people can work at. And so I think it's been really successful. It's been a great space for people to do exactly that, study either together or separately, just hang out between classes during the day and do some studying in a space. And so that's been really great. The students, I think, yeah, have also just come to use the space really well. And then I mean, every year is a little different, right? Like every set of 20-ish students will bring a different flavor to their interactions with each other. But we have a great set of students now across the sort of years, the main years of the physics major, and they motivated to sort of make their own field trip to go to LIGO in Washington. So that's the Gravitational Wave Observatory. And so I said, I mean, they asked for funding, and I was like, yes, of course, we'll pay for to pay the drivers and the cost of having the Reed vans. And they organized a trip and went and saw LIGO over, I think like 3 weeks ago or something. And it sounded like it was a really super fun trip. So that, I mean, that doesn't happen every semester, but often, if the student have a great idea for something they want to do, the department's super supportive. Over the summer, during whoever's here, whether it's research in the department or elsewhere on campus, we have summer barbecues all summer, bringing faculty and students and staff together. We usually have a summer hike or outing as well. Yeah. And then I think like the weekly sort of bring everyone together time is really those seminars when we have the tea and cookies beforehand, and then we go and hear about some cool physics in seminar.
And what sort of experiments are covered in advanced lab?
Yeah. Well, I haven't taught it. I know there's like a muon detector. What else have I heard of? Um, But I don't know all the experiments of advanced lab. I know the ones I teach in sophomore lab. We're doing a new one this year called the Frank Hertz experiment, which it was really fun. We do one that measures the speed of light, photoelectric effect, some of the basics from modern physics era, but I don't know all the ones in advanced lab. Sorry.
No, and that's okay. And I think you're starting to touch on this next question, which is what are some examples of other exciting research going on in the physics department as a whole?
Yeah. So I mean, who should I even cover? I don't know. We all do really cool things. So Jennifer is working on 2D materials. They're really fun. They get a ton of press because they have so much fun physics. Like 20 years ago, no one knew. But 2D materials where you basically have electrons confined to a surface of a material or just a thin layer of it. And there's all sort of fun electronic properties show up for various quantum mechanic reasons. And so those are some things she studies experimentally. Daryl studies similar things theoretically. The sort of fun topological states of quantum matter. Noah is also sort of in that space. What is Lucas's most fun thing? I don't have everyone's research dialed up. My work is working on turbulence in nearby galaxies and how that is or is not important for regulating star formation. Yeah. So I think that's at least a little bit of a flavor. I hope that helps.
Yeah, for sure. Do you mind, and this just popped in my head, sort of in this topic, do you mind talking a little bit more about, I know we have a current student who was one of my students, which I'm really proud of that I got to recruit, discover some planets. Do you mind talking a little bit about that?
Yeah, and so that was through a summer opportunity that that student found on his own, working with an MIT researcher and working with in Astro, we have really publicly available data. And so working with publicly available data was able to do the data processing to show that there were additional planets around this one star and not just the initially discovered exoplanet, but actually additional transiting exoplanets. So yeah, it's super cool.
Yeah, definitely exciting. And then is the Reed physics program more theoretical in nature or experimentally focused?
I think we're both. So we have like three experimentalists, three theorists, and then me, who like kind of doesn't fit in either category because we observe in astronomy. We don't like actually have experiments because galaxies are too far away. Um, so I think we're pretty evenly divided, and I think our curriculum sets people up to do either really well. And so we have at the thesis level, we have theoretical theses, we have experimental theses, and I mean, year to year, they might lean one way or another, but that's just because of the interest of the students.
And then for our last question, what is your favorite part about Reed?
What is my favorite part? I just love that it's a community where everyone loves learning. That's the fun thing, right? It's so much fun to learn new things, and I get to learn new things all the time. Um, Sometimes it's in teaching. I appreciate something that I hadn't like really fully appreciated before I decided to teach it and wondered about this one little aspect. And sometimes it's I go to a talk in the Russian department and learn something that I had never even thought to be thinking about, the culture of theater in the 1960s in the USSR. Like I wouldn't have run into that in any other place. So I just love that I have colleagues that are interesting, curious people and students that are interesting, curious people. And that makes for a super fun community to be part of.
Wonderful. That was our last question. Allison, I just want to say thank you so much for taking the time out of your day to tell us a little bit more about the physics program and allow us to hear more from your perspective. I know I found this helpful as a staff member, and I'm sure our attendees did as well. For everyone else, thank you all so much for attending. I hope this was beneficial and useful as you're sort of considering Read or considering sort of next steps. For those of you that have been admitted, congratulations once again. Our decision deadline is coming up on May 1st, and our seats are filling up quickly. So definitely encourage you to reach out to your admission counselor if you do have any lingering questions. That being said, thank you all so much, and everyone have a great rest of your day.
Bye.